Good morning, this is Ian Bennett from Ordnance Survey, and I'd like to welcome you to our webinar today on using Ordnance Survey data for GIS and business analytics for public health. And I'm joined today by Ian Usher and Fergus Craig, who are going to be using their CADCOM software to demonstrate the benefits of using GIS in this way. Before we start, just a couple of quick housekeeping points. One, if you could mute your microphones, please, because that prevents any feedback. And secondly, we will take questions at the end. Please feel free to post your questions during the session as you think of them, but we will answer at the end. There may be some questions that we won't be able to answer straight away, and we'll take offline, and we will get back to you as soon as we can. So thank you very much for joining us. As I say, this webinar is about using GIS for public health. And what we want to do is look at how you can use GIS, a geographic information system, for handling large data sets, for displaying health data, analysing that and providing insight into the distribution of health resources and services, and identify where the gaps are in your service. Hopefully this webinar will demonstrate how you can gain maximum value from a range of Ordnance Survey data products and for use with CADCOM software. The examples we're going to cover, we will look at location allocation models, so how you can use location to allocate resources. We'll look at routing analysis for identifying how accessible facilities are and for looking at patient travel. And then we'll also look at combining population and demographic data for improving distribution of your health resources, as well as looking at how you can use Power BI to make interactive data visualization. So we're going to quickly just have a couple of poll questions. So the first one, does your organisation use a geographic information system? If you could just answer yes or no. So is anybody else wanting to vote? I think the majority of you voted. So you've got one person who can't hear anything. So thank you very much for the responses there. The majority of you are using a GIS. And so the second poll question, is your organisation using your GIS for planning and allocating of health resources? So just a few more of you left to vote. Has anybody else not voted? So looking at that, about half of you are already using GIS for in this way. So hopefully by the end of the day, the rest of you will see what it is you could be doing, and I'll get some ideas which we can talk to you about. So Ordnance Survey has a range of spatial data set that you could use for this. We have base mapping, such as our zoom stack, and then we have things like our addressing data, address-based code point. So you can look at individual addresses and then map them at an appropriate level, appreciating you cannot release data at an address level, but you can analyse and then look at an appropriate way of mapping that. We've got administrative boundaries, which you can use then to amalgamate and synonymise data. We go down to ward and parish levels and right up to county and regional levels. We also have detailed mapping which you could use for analytics, including our base mass map topography layer, which is the detailed data our surveyors are capturing, and our highways network for an open network. And we also have a suite of open data sets. So this is what they look like. And if you've been to one of our events, you might have had this as a takeaway screen, and in the top left-hand corner you can see the detail of our mass map topography layer, and you can see there's various raster and backdrop data sets there. There's not really the time in this webinar to go through all of these, but if you've got questions about these, I'm quite happy to take them or to talk about them offline. So how do health organisations access this data? So if you're in the public sector, you've got the public sector mapping agreement, which gives you a wide range of data sets. Organisations outside of the public sector, you may be a contractor working for a public sector body, so there are arrangements that can be put in place with that public sector body to give you access on a project basis to the data that you need, or you can either come directly to Ordnance Survey to buy data, or you can get that via an OS partner such as CADCOM, to whom I'm going to hand over to now. So Fergus.
Thanks, Ian. My name's Fergus Craig from CADCORP. I've got a few slides to introduce CADCORP and talk to you a little bit about the technology before I hand over to my colleague Ian Usher, who's going to be using CADCORP technology to demonstrate these concepts using Ordnance Survey data as well. So CADCORP are a UK-based developer, and we create the spatial information system, which we call CADCORP SIS. That's a web, mobile and desktop GIS mapping applications, and it supports all Ordnance Survey map data. We've been doing this for a really long time, so we're experts in this field, and we focus on the development of the software and the implementation, such as installation and training and those kind of services as well. The spatial information system, as I said, is a web, mobile and desktop mapping application. So the web and the mobile provides an interactive and dynamic access to geographical information data, and the desktop applications have a lot of functionality for detailed analysis. Accessing this kind of data, as we'll demonstrate when Ian takes over in a few minutes, provides knowledge to improve decision making within the public health area. To introduce the technology itself, and this is what Ian will be using in a few minutes. This is CADCORP SIS Desktop. This is a desktop GIS application that has all of the desktop functionality that CADCORP provides. As you can see here, you can theme data based on boundaries, bring in your own business data, bring in all the Ordnance Survey data into one place to carry out visualization, analysis and reporting geographically on this data. The WebMap application, CADCORP SIS WebMap, is a really similar application, but it's accessed via a web browser. It's designed to be really easy and intuitive to use, so anyone can pick it up and use it. It doesn't need specialist training, and we're going to be using this to provide some examples again shortly. In recent months, CADCORP have been creating an integration with Microsoft Power BI to enable our customers and other organisations out there as well to bring Ordnance Survey data using CADCORP technology into the Power BI visualisation environment. Power BI is excellent. Many organisations have access to Power BI, and as you can see here, it's great for visualizing charts and graphs and visualizing data in this type of environment, with the added benefit of being able to drop in a map, so being able to integrate with those geographical elements as well, which we'll cover in more detail. So why CADCORP? We work with the Ordnance Survey really closely. As I said, we support all the different data sets, all the information that the Ordnance Survey produce can be supported within CADCORP technology. We've been doing it for a long time, and desktop GIS is really important to CADCORP. Although we do have cloud-hosted web applications as well, we continue to concentrate and invest in the development of our desktop GIS. That provides the ability to connect to lots of different data sources, lots of databases, and the dynamic connection to these data sources ensure that the data within the application's always up to date, and the web mapping is available to an unlimited number of users as well. The applications can either be cloud hosted or they can be on-premise hosted, so there's loads of flexibility for CADCORP technology.
Okay, and so what we're going to do now is we're going to look at a demonstration of the software and the kind of things that you can do. So looking at the list in front of us, we are looking at the location of and allocation of our modelling. We're looking at how we can use routing analysis to identify and facilitate response to patient trouble. how we can combine population and demographic data as an example to improve distribution of our health resources. And then finally, as we saw in the screenshot, we're going to look at how we can use our Power BI with spatial data to provide interactive and dynamic visualizations as well. Okay, so what I'm going to do is I'm going to go firstly into our CADCOM desktop software. So the first thing I'm going to say is that this is a live demonstration. So if at any point what I'm doing doesn't make sense, then let us know and we can stop and take a look. But what you'll see here is we've got our CADCOM desktop software, and one of the first things that you can see is we've got our GP boundaries, and we've got small points on the map which at the minute represent our Nottinghamshire patients. So firstly, what a user could do is they could use the gazetteer search that exists in the desktop, and they could search for an address or a postcode, and the system will navigate them nicely. So that's using the address base that Ordnance Survey provide. But what we're going to do is we're going to zoom in. So what you'll see as we zoom in through the application, the different mapping levels that we get as we come through. So this is providing all of our mapping to our NHS authorities, and we can go right down to kind of our lower level master map data that kind of highlights where the buildings are and the building names, road names, bus stops, and things like that as well. So it goes into kind of really detailed master map data. So what we're going to do is we're just going to zoom out a little bit, and I'm going to say that we've got a new patient that we need to add a particular address. So like I say, what you would do is we can say that we want to add a new address to our Nottinghamshire patients, and we're going to say we want to create a brand new point, and what I'm going to do is I'm going to drop that point over a particular address on the map, and you'll see straight away that our system has got the point where that patient is. What we can also do is if we say we go to properties, we've got a dynamic expression that's been built on that overlay of our Nottinghamshire patients that shows which GP boundary they fall in automatically. And because that's dynamic, if we were to change the location of that property, say we got the wrong address, for example, if we were to move it over to the other side of the street, what you'll see is that as it moves, if I then select that point, as we select the patients, what you'll see is that it's now moved to our Fountain Medical Centre. So the system's really good at recognising all these kind of spatial expressions that allow you to really easily see what's happening with the patient data. So now that we've got the patients in there, what we can now do is we might want to simply add a theme that shows how many patients we have within each of our GP boundaries. So what we can do very easily is we make it really easy for users to create these dynamic expressions. So under our schema column, we're going to right click and we're going to say that we want to add a spatial expression. And there are different expressions that you can write. So we could, like we did before with the Nottinghamshire patients, we can tag what GP boundary they fall in. In this example, what we're going to do is just simply say that we want to create a count of our patients. Because we're adding this to the GP boundaries, I'm going to say that the count that we want to do is our Nottinghamshire patients. And as part of the wizard, what we can do is we can say that we want to change that column. So we can say count patient. And then we're also going to include a map tip and a prefix so that we can hover over the data and see the information that's available to us. What's important is that it's never creating a static number. So this calc interior is creating a dynamic number, a dynamic count of all those patients that exist within that particular boundary. And we'll see how this data changes as we step through. So when I click finish, what happens is as I hover over a polygon, you'll see that we've got a count patient there that exists that's got 14. We go to another GP boundary that's 45. We go to another one and we've got 54. So it's added all of the counts of the patients to those particular areas that we've got set up. To support our numbers that we've got, what we might also want to do is we might want to add a theme to visualize the data. So if I go into add theme, I'm going to say we want to add a theme to our GP boundaries. There are lots and lots of different themes that can be added, but today we're going to concentrate on only a couple of them. So the first one I'm going to do is we're going to say we want to create a range theme. And then we identify the column that we are counting. So we're going to use the count patient, and it's using that calc interior that we've just set up. So when we click next, the system presents a default number of ranges that you can use. What I'm going to say is that we want to create a range of 10, and we're also going to say that we're going to include natural breaks as well. And then what we can do is we can say that all of these ranges have all got a black outline, which is changing that pen. And then rather than choosing each individual range theme, what we can do is we've got a color swatch built in that allows us to say that we want transparent, reversed, diverging, spectral. So high numbers will be red, lower numbers will be blue. And when we click OK and click finish, straight away we can see the visualization for the number of patients that exist within each of our GP boundaries. So that's really good at counting the number of people. If I just zoom into a particular area, what we can also do is we can be really specific. Rather than you watch me add an annotation theme, I've got one that's already set up. So now we can add numbers to that show where our what numbers we have within each of our GP boundary. So as I've said, all these numbers are dynamic. So what happens, what could happen, and we're making dramatic changes, which probably won't happen in a real world environment. What it could say is we've got a number of GP boundaries that have got low numbers. So what we might do is look at amalgamating these boundaries into one. So what I'm going to say is that I'm going to edit my GP boundaries, and what we will see is if I hold shift down, I can select multiple boundaries at the same time. And then when I've selected all the ones that I'm interested in, we've got the tools that can really easily say that we want to go into our analysis and we want to create a union based on these. So the wizard that comes up asks us which is the boundary name that we want to keep. So we can keep our South Glade Medical Centre. And when I click select, what happens is that it amalgamates all those boundaries into one. But the really impressive and important bit is that it takes over the account of the patients, and it also changes the labelling and the range theme. So now you can see that actually that might be over-resourced based on the themes that you've got set up. So it allows you to pick and change it, the kind of different setups that you might want within the application. What we can also do is we can look at maybe moving the boundaries as well. So what I am going to do now is if we add in our if we were to say that we want to look at the number of patients within an area and we want to change the boundary, for example, what we can do is we can say that we want to select the line that exists in between, and we can select it. And then what I'm going to say is that maybe we want to change the existing boundary that's been set up. So in this example, we've selected the line that exists between the two GP boundaries. And what I'm going to do is just simply move the nodes that exist. So what you'll see if I start moving these, what happens is that it takes into account the it takes into account the boundaries of everything. And what you'll see is that it's counting the patients, and it's also changing the labels and the themes as we are changing them. So we went from 28 on the one that we've got selected to, I think 16 is what we've got, 18 is what we've got, and then we've changed that. So it allows us to interact with the different GP boundaries that we've got set up, and we can make small changes as well as the big dramatic changes that you can see in front of us as well. So that's kind of the location and allocation side. What we can also do is look at kind of our routing analysis. So in this example, we're going to use the OS master map highways data. So in its basic form, what it allows us to do, or what we can do using the highways data and then the CADCOM desktop software, is we can really easily create a measure. So we've got a routing tool application that allows us to say in a basic term that we want to create a measured route. And we're going to base this on our highway speed data, and we're also going to create a line to identify what the route has been taken. So when we click OK, we can click on a position that we want to start at, and then we can click on where we want to end. And what the system will do is it will work out the best route for that line that we've, or those 2 points that we've selected. And using the road routing information, it goes away and the system's clever enough to come back and say, right, based on the highway speed that you set up, that route is going to take you 4 minutes and 48 seconds, which is great when you're creating measure routes, but it's also good when you look at kind of patient analysis going to and from different GPs, which is what we'll do now. So one of the first things that we'll do is we'll say that we've got our GPs, we've got a smaller sample area, so we've got a load of GPs in front of us, and we've got our patient locations, which are the green dots. And each patient location has a preferred GP attached to them. So what we can simply do in our routing points is we can say that we want to create a match point, and we want to go from our patient shortlist to our GP shortlist. And what I'm also going to do is I'm going to take over our GP name as we go. So what we can do is we can base this on a highway speed, but in this example, just for the time being, we're going to say that we want to draw a straight line between these points, and you'll see why in a second. So when I click OK, it tells us it's going to 159 matches, which have been found, which is good because that's the number of patients that we've got. And then when I click yes, you'll see all those routes are being created. And in a second, what we can do is we've got straight line analysis that we've used, and it's identified where those patients are. Rather than you watching me create another theme, what we can do is we can add a save theme into our software. So we've got all the GP name saved. So I'm going to say I want to add a save theme using our GP routes, and when I click finish, all those routes are styled up quite nicely. So now we can see where each individual patient has travelled from in order to get to their preferred GP. What we can then do is we can look at how, looking at our GP locations, we can look at how far we can kind of travel from those particular GP areas. So what I'm going to do is I'm going to select our Farnsfield GP, and we've got the option of creating isochrones. So if I say we want to create an isochrone, we've got travel limits that we want to enter of 2, 4, and 6 minutes. There's different options, and we're going to come back to this in a second. And then what we're going to do is we're going to base this on our highway speed. So it's important to note as well that the highway speed that are attached to this data set are using the average road speed data from BaseMap. So that's been included as part of the join. So it's giving realistic road speeds rather than the motorways are 70, A roads are 60 and things like that. So we're going to say based on a highway speed, we want to know how far we can get within 2, 4, and 6 minutes. When I click OK, what you'll see is that straight away we've got an isochrone that follows the road network, and by the colours that have been applied, we can see the greens is 2 minutes, the yellows is 4 minutes, and the reds is 6 minutes. That allows us to see the kind of the drive time location from that particular GP boundary. What we can then do is we might want to then say, well, maybe we want to create a polygon of a 5-minute drive time, for example, around that particular boundary, around that particular GP. So I'm going to go into our routes. I'm going to say I want to create an isochrone. The travel time is 5 minutes. And what I'm going to do on this occasion is fill that isochrone so that we can see kind of the boundary that's been created from the GP boundary that we've got set up. And again, I'm just going to apply our highway speeds and click yes. I haven't got that GP selected. Select it again. Go into isochrones. We're going to say 5 minutes. We're going to say fill isochrones, and then it comes up with the highway speeds. So now we can see that polygon has been created, and we can see where the overall drive time is for that 5-minute drive time from our GP boundary. But what we can then do is if we lay over our match point analysis and our patients, what you'll see is that some of the patients have chosen to drive or walk within to the nearest GP outside of that 5-minute drive time. So there could be a reason behind that because of the services that are provided. But you're getting into kind of the really nitty-gritty analytical side of the why patients are travelling to and from particular areas using the OS highway speed data road network. Okay, so that's kind of our route analysis. And then what we're going to do now is look at our population and demographic data. So if I turn our data on again, so what we have here is our LSOA boundaries. Attached to each of our LSOA boundary is simply, we've added 2 attributes, and these have come from our census boundary information. We've added kind of our age of number of residents that are between the age of 45 and 59, And then we've also added a count of the males that are within those particular LSOA areas. And what we want to do is basically a theme to say where the number of people are with that age range and where they are male. So what I'm going to do is I'm going to say that we want to create a theme, and I'm going to say, because we're using two different attributes, we've got the option of saying that we want to create a BIvariate theme. So this allows us to choose two different attributes that exist on that data. So on our x-axis, we're going to say that we want to create a range theme that's based on our 45s to 59s. And we're going to say we're going to keep the number of ranges as 3, but we're going to add natural breaks in there. And then on our y-axis as well, we're going to say we want to create another range theme based on the number of males. And we're again just going to say we've got natural breaks and click finish. The system brings up a default color swatch to start with. But what we can then do is we can say that maybe the pens are transparent red, amber, green that we've got set up as is the brushes. And then what you'll see is that it gives us the colour scheme on the left. So just to briefly say that the bottom left will be where we have less 45 to 59s and less males. And then the top right is where we've got the majority of our 45 to 59s and the majority of males. And anything between depends on which axis it falls on to tell us whether we've got high 45 to 59s and low males and likewise. So when we click finish, the data's seen quite nicely. And what you'll see is that it provides patterns in the data, so we can see kind of the red areas, which are the higher 45 to 59s and males, seem to be, the majority of them seem to be outside the GP boundaries. So maybe that's something that needs to be looked at, or maybe we need to export the data. So what we can do now is, if we go into our query builder, we can actually write these expressions to pull the data out of the application as well, or maybe filter it so we can see more defined areas. So what I'm going to say is this time we are writing an attribute query, so I'm interested in anybody aged 45 to 59, and the numbers I'm after are anybody is the count where they're over 100. And what I'm also going to do is I'm going to say that we're after the males where they are over a count of 200. So when I click next, the system allows us to do multiple different things with the data. All we're going to do is we're going to say we want to filter that data. We can decide to show the data, so we can show that there's something coming through because we wrote an expression, we can see where that data is. And then when I click finish, because we've chosen to filter that data, it's now only pulling out the really specific information that we're interested in. So this allows us to then export that data, or we can share it on kind of our WebMap application, or like I say, export that data and put it into Power BI so we can analyze it further if we need to. Okay, so as we said, this is a really good place to kind of save the data. And then what you can do is you can distribute that using a web mapping application. So what we're going to say is that we've got our web map application that allows you to visualize and query spatial information through a website, a web environment. So it's designed at simple use for end users. Again, the Ordnance Survey data that we've got looks really nice because it's the zoom stack data, and as you zoom in through the multiple different levels that have been set up, because it's a zoom stack, it's providing a consistent base mapping. So you can go all the way down to a particular area that you're interested in, and then right at the end you'll get the kind of the master map data that is presented to you, because we've added the master map data to the bottom bit. But primarily what this tool is aimed at doing is aimed at sharing the results that we've just got. So if we go into map features, I might say that we want to look at our, you've got the option of looking at your ward boundaries, so we can look at the GP boundaries and things like that. We can look where the GPs are, but then what I've also got is the patients' locations we can see as the dots, but then we've got the 45s to 59s that we've just created that's allowing us to see the results that we've literally just created in the desktop presented within the web mapping application as well. There's a really good way of sharing the data between different applications and users. What we also have the ability to do is you can analyze the data through different modes. So one of the ways of doing the analysis is to look at an area of interest. So we're going to look at our Farnsfield site, and as a user, you might be interested in only a particular area, so you might want to draw the area that you're interested in. So using our editing tools, we can say that we want to edit a custom boundary, and that boundary is going to be made up of a polygon. So the user would then draw the area that they're interested in. So I'm interested in the whole of Farnsfield, we've set it up. And when I double click, I can add an area name. So I'm going to say this is our Farnsfield area, for example. And when I click save, it tells me it's added that feature. And then what happens is that it picks up on the boundary that's been drawn, and it displays labels that apply to the information that's held underneath. So I can see from this that the boundary that we've drawn falls within our Farnsfield CCG area. We instantly get a patient count, which tells us 112. We've got the male count, which is 53, the demographic type, the average drive time to the nearest GP, things like that. So it's a really informative way of users being able to create a custom area and then getting information back based on the same spatial expressions that you've just seen created within the desktop, coming through straight to the website. So it's a really good and intuitive way of getting information out of the application. And then finally, the last thing that we can do is we can bring kind of all the information that we've gathered today, we can bring that into our Power BI application. So this is the Power BI application is designed for analysing data with bar charts and pie charts and other different analysis, counting items and things like that. But what we've recently done is we've given users the ability to take spatial data in OSGB format, which is really important because all your data is going to be, the majority of your data is going to be held in the OSGB format, a coordinate reference system. So we've given you the option of taking all that data, not having to convert it to lat long, and put it into the Power BI with an Ordnance Survey mapping base. So something that users are already paying for and are familiar with gets put into the Power BI application. And what happens is that as we click on all of our different bar charts, as you would expect with the Power BI, if you've used it, you will know that as you click on a particular bar chart, all the chart changes and the patient count changes and the average age changes and things like that. But more importantly, the map navigates to where you've selected that data. So we've clicked on our Clifton ward and we can see kind of the 8 patients that have fallen within that ward. We've got a hotspot map that we've got held underneath. So all of this kind of data could have a base map underneath. So when we click on particular areas, it will navigate, and you could have flooding in there, you could have the locations of GPs, but it's all being referenced from the same project file from the desktop brought into the Power BI stuff. And we've also got the option of turning that off. So if you didn't want the KD, for example, and you did just want to see the customers, the patients, if I click on one of our other GPs, what you'll see is it's navigated us right down to show where those patients are. And again, it looks really nice with the Zoom stack data in it, in order for users to be able to interact with the data, and we can see where that information is held, and it's all dynamically changing as we see fit. So that's a really good way of sharing the data out using the Power BI application as well. So that's kind of the end of the demonstration from me. So what you've seen is the ability we've used the desktop to do the kind of location and allocation of the models. We've used the desktop to look at the kind of the routing analysis for our patients and GPs that they are visiting. We've used the population demographic to look at creating a BIvariate theme with multiple different attributes. Now we can share that to the website, and then giving users the ability to really easily create their own custom boundaries in order to create to do their own analysis within the web. And then finally, we've looked at how the Power BI can incorporate the Ordnance Survey data in the OSGB format in order to provide dynamically changing charts as well. So what I will say is that that's the end from us. If there's any questions, we're happy to take questions now, or we've got contact details for both Ian Bennett and Fergus Craig on the screen if you wanted to get in, wanted to talk to them further.
So thank you very much, Ian. That was very informative. So thank you for that. And as you can see, our contact details, as Ian said, are on the screen for either myself or for Fergus. So we've got a few questions that have already started coming through. Thank you for those questions. The first couple of questions are around routing analysis and whether this can be done to focus on walking, looking at walking distances for including pedestrian footpaths, or extended to include cycling. Can you sort of expand on that, please, Ian?
Yeah.
Yes, absolutely. You can, within the CADCOM Sys desktop, you can choose which network you utilize within the application, and you can apply different speeds appropriate for walking or cycling. So the answer is yes. There is even more detailed analysis you can do to look at height data and bring that in for cycling as well to analyze where flattest routes are. There's lots of tools available to you to utilize that type of data. So yes, you can.
So I think that answers all the first few questions around that. If you've got any more, please come back to me. So the next couple of questions around customizing the Power BI. So the customized Power BI visualization you've used, is this only accessible with a specialist license?
The Power BI visualization has been created by CADCORP. It's just about to be released, so that's probably why you haven't heard of it yet. But it's a CADCORP created Power BI visualization. So yeah, it's something that CADCORP can provide to you to work with CADCORP technology. If you're a CADCORP customer, then you can use your existing CADCORP technology within that. If you're not a CADCORP customer, then we can help you out with that and set you up with the appropriate services to bring OS data into Power BI.
And so the second part of that question is around the mapping that you're using, that it doesn't seem to support the same desktop base maps. Is that something else that you can help people with?
Yeah, so the Power BI integration enables you to pick up data that's already within your CADCORP application. So any data that's supported within CADCORP Sys, as I mentioned, there's over 300 different data formats, but that includes all Ordnance Survey data. So what I think is really powerful about the Power BI integration is that capability to bring in OS master map data, as you saw in Ian's demonstration, within the Power BI environment. So you've got master map, but really detailed mapping you obviously are familiar with, bringing that into the Power BI environment so the end users of that application can see that level of detail, which you're probably familiar with using within GIS and web mapping currently.
And so the functionality that you've been demonstrating today, is this all included in the standard CADCORP Sys desktop product?
Yeah, good question. So there's a mix of applications that we showed you today. So everything that you showed within CADCORP Sys desktop is included. CADCORP don't produce and sell extra bolt-ons or additional licenses. Everything that we do in desktop GIS is included in CADCORP Sys desktop. So there might be some add-in apps which you can download for free from our website, so customers have access to those, but there's no additional functionality. Ian also used CADCORP Sys WebMap, which is a different license to CADCORP Sys Desktop, and also the Power BI visualization as well. So there's a few different options there, but do get in touch if you want to know more about those, and we're happy to talk you through those.
Okay, so are all the traffic speeds, so the next one is about road speeds, are they included in CADCORP Sys so that they can we provide further information on that?
Yes, so average speed data from the Ordnance Survey, for example, that can be utilised within the application. So the answer is yes, and yeah, we can provide you further information. We've got your contact details through the questions, so we'll get in touch about that further.
So thanks very much for those questions, and thanks very much for listening. I do apologise because there were some sound issues we were aware of early on, and hopefully that wasn't too bad. We will make a recording of the webinar available. Are there any more questions? So if there are no more questions, thank you very much. We'll sign off now. Thank you for joining us. As I say, we will make a recording available on our YouTube channel. Thank you very much. Bye-bye.